So hey guys, welcome back to another lecture. So first of all, congratulations that we have completed two modules, which is vectors and matrices. So today we're going to cover a new topic which is called as a calculus. So what do you mean by calculus? So we're going to cover a lot in the calculus. Calculus is just a branch of mathematics that deals with the finding and properties of derivatives and integrals of a function. So I just give you a simple definition, like, so a calculus is just a branch of mathematics that deals with the finding and the properties of derivatives and integrals of the functions. In a simple word, so the calculus is just a branch of mathematics that deals with the rate of change. So how much this changes, when that changes, etc. Just a kind of a that kind of example is just a rate of change. So for example, you may want to calculate the change of a velocity of a car rolling to stop the red light here. So we used to find out in our real life problems. So I'll give you a brief explanation out there, so just leave it. So I'm going to cover what I'm going to cover in this lecture. So I just want to give, so okay. So the first I want to cover what is calculus. So I just want to cover what is calculus, and I want to cover the second I want to cover differentiation. And third I want to cover integration. And we have a different rules over here. We have a different rules over here in the differentiation and integration, and after that we have a limits and trigonometry also. So I want to cover all these in a great detailed way. So I hope you enjoyed this lecture. So if yes, then please like and share with your friends who are needed. Okay, so I'm gonna start with, like, what is calculus. So as I said now, it's just a branch of mathematics that deals with the rate of change, right? So it's just a branch of mathematics that deals with the rate of change. Okay, so what is calculus? Just I want to give a basic and a general example. Like, so the calculus is the advanced version of algebra. So we have discussed in a linear algebra, right? So it's just an advanced version of that algebra and geometry. So the calculus is the advanced version of algebra and geometry that deals with the curvy graphs. Okay, so that deals with these kind of graphs. Okay, so these kind of graphs. So it's just a branch of mathematics that involves the study of rate of change. How much, like, what is the rate of change? So for example, like, how much this changes when that changes, like, so how much x changes when y changes, how much x changes when y changes, etc. These kind of examples comes for the rate of change. Okay, so we have example of miles per hour, etc. And we have a as I said in a previous example, like, so how much changes, how x changes and y changes, like x changes and y changes, etc. So it's an advanced version of algebra. It deals with the rate of change. So I think I have given a basic introduction of the calculus. So how we use in our real life, you may get doubt, right? So how we use in our real life, right? We use calculus daily in our real life. So how we use? So if I have a tower, I have a two towers, bro. So I have a two towers here. So I have a two towers, and I want to find the length of the wire which is attached to these two towers. So which is attached to these two towers. Okay, so if I want to, so in a regular math problem, I just find the distance from the T1 tower 1 and to tower 2, and I can say that it has a 100 meters, or that 100 meters or 50 meters, etc., whatever it may be. So this is the length, but the line have a curve over here. The line have a curve over here. So how we find that curve? And how can we find the length of the wire without like having not a straight line with the regular math problem? So this is called as a calculus. And the most so the calculus, as I said now, is the most used case in our real world. So we used to see a lot of examples. You can find a lot of examples in the calculus in your real life. So how we find this length of the wire? So I'm going to explain in our further lectures. So please subscribe, and I wanted you to know by your own and I also explain it, but I just wanted to stop this lecture. I just want to stop this lecture and just research on your own and then come back. Okay, I hope you do that. So how we find the slope? How we find the slope? How we find the slope of that line? So if I taken a right angle triangle, if I had taken the right angle triangle, and this is run, and this is rise, right? So this is run, so it a horizontal one become run, and we have a vertical one we become rise, vertical become rise. So and we have a slope out there. This is also called as a steepness. Okay, so the slope or steepness, so I just want to find the slope of this line. So how we find the slope of the line? So the slope of the line is rise over run, which is equal to, which is also equal to y2 minus y1 by x2 minus x1. We're going to have this formula in our further lectures, don't worry. So I'm just giving an introduction to the calculus. So what is the slope? How we find the slope? It is a rise over run, right? So it is a, if we have a data points and all that, we're going to plug in this formula over here. So we have x value, y value, x1, y1, etc. So we're going to plug this formula and we get our slope of this triangle. Okay, I hope you have a basic idea of this calculus. So I'm just giving another example, like, so it's just a regular math problem, right? So it's just we find a slope, but here we have a curved line here, as we discussed in our tower example. It is a curved line, right? So the slope changes every time. Maybe the slope is different from here to here, here to here, here to here, etc. The slope changes, but here the slope is constant, bro. The slope is constant. Here the slope changes. From at every point. So you can take the slope at a particular point on a slope curve. You can take any slope, any current slope at a particular point so I just want to take here, here, whatever it may be. So here, to calculate that slope, here we use the calculus. Here comes the calculus. So I just explain it clearly. So as I said in our tower example, right? So how we find the curve, how we find the length of that curve, and what is the angle between that. So we're just going to we're going to find with the help of the differentiation and integration. Okay, so how we find this curve length, how we find this slope, right? So how we find this slope, it's a big question, right? So we're gonna answer in just a few minutes. Okay, so we have two big ideas in the calculus. We have two different kind of ideas in a calculus. So the one is differentiation and the second one is integration. So the one is differentiation and we have a integration out there. So why we use the differentiation? We use it for take out the slope. So how we take out the slope at a particular point? We have a dy by dx. So another way is we take a partial derivative. This called as a partial derivative. I'm going to clearly explain in our further lectures. So complete lecture on differentiation and a complete lecture on integration I'm going to cover in a detailed way. Okay, it's just a basic introduction to the calculus and what are the different kinds in our calculus, etc. So I'm just giving a basic introduction. Okay, so differentiation. So it's just a process of finding the derivative of a curve. So as I said, now it's just a finding of a derivative of that curve. It find the derivative of this curve. Okay. So and the word derivative is a fancy word, right? So it's just a fancy word of a calculus for the curves of slope or steepness. So it's just a differentiation means like it's just a kind of a weird word, right? So it's just a kind of a different word, but it's just a calculus term to find a slope, to find a slope of this or a steepness of that curve. It's just a fancy calculus word to find that slope of the curve. We use a differentiation. The word is differentiation. Okay, because the slope of the curve is equivalent to the sample, right? Then they're equivalent to the sample, right? Like meters per hour, or so product per item, etc. We have a product per items, etc. The derivative is a rate as well as a slope. So if we have a equivalent over there, so I'm going to give if they have a relationship, then the derivative is a rate as well as a slope. I hope you're getting it. So if we have a relationship like meters per hour price per quantity, or product per item, etc. These kind of example, right? So the derivative is like a rate and also as well as a slope. Yes. So how we find that? So the m, as we discussed, right? So how we find the slope? Rise over run. If we have a x1 and y1, x2, y2 value, we just simply plug in this in a formula, y2 minus y1 by x2 minus x1, and then we take this like this. Like how we say that how much x changes when y changes, how much x changes when y changes, right? So like x over change in a y. So like how much this changes when this changes. I hope you're getting it. So I just want to give a geometric view so that you can understand in a better way. So I just want to give a geometric view. So I just want to, it's a regular math problem, right? If we have a this, but we have a curve over here, this is c, right? This is c. So the slope of the curve is constantly changing from point A to point B. So as I said in a previous lecture, so the slope is always changing. It's not in a particular point, right? So the slope, it may be like in many points, as many as point. So to calculate the slope at exact point, so I just want to find slope here, or I just want to find slope here. So we just simply zoom out like a, if the curve like here, so we simply zoom, we simply infinitely zoom, then it will become like a straight line. It seems like a straight line, right? So just see, like we zoom infinitely for that it can form as a straight line. So if you like this, and if we I'm just giving you, so this is a curve, bro. Just stop the lecture and take a screenshot and just zoom it in a as possible as you can, and then you find that a straight line, in the curve. I hope you're getting it. So based on this limit property, I'm going to discuss what is limit property in our further lectures, but do what I said, like take a screenshot and zoom it how much as you can, and please look at, like you're gonna look a straight line, right? You're gonna look a straight line. So this we find the derivative of that curve. So after differentiation, so what do you mean by differentiation? It is used to take out the slope of the curve, right? So it is like that. So what is integration? You may get a, right? What is integration, right? So it is the area under that curve. So the integration is just, I just want to find the slope, but the differentiation is this the area under that curve. So I have given a clear example right here. So we will look at it. So it is a process of cutting up an area into tiny sections and figuring the areas of small sections and then adding up in a little bit of area to get a whole area. What is saying, right? So I just simply example, like, so what is integration? It's just to find a area under the curve, we use integration. So I just want to find the slope of this curve, then we use differentiation. Under the curve means integration. So we just simply make it into a small parts, and then we simply combine all that, and this will become a integration, right? So this all tells the same thing. We just simply make small sections and then adding up into our little bits of the area and getting the whole area. I hope you're getting it. So the area under this curve, is integration, right? So it is the integration. So the slope of the curve is differentiation. And the area under that curve, under a point A or point whatever it may be. So the slope of this under the curve, is integration, and the slope of the curve is differentiation. So I hope you have a basic understanding of the differentiation and integration, and a basic introduction to the calculus. So what is calculus, and what are the differentiation and integration, how we use the calculus in our daily lives, like how we find the length of the wire. So how we find, like, you don't know, right? So I'm going to cover further lectures. So I just want to give an outline for this until now. So I just want to give outline. So what is calculus? So what is calculus? It's just a branch of mathematics that deals with the rate of change. Means like how much this changes when that changes. Okay, how much this changes, how much x changes when y changes, how much a changes when b changes, etc. This kind of stuff. Okay, so I have a 1 liter of petrol, so it will take to 50 kilometers, like, so I have 1 kilometer. How much this liter changes when the kilometer changes? It's a kind of relationship, right? If I have a 2 liters, then it become 100 kilometers. If I have a 3 liters, and it will become 150 kilometers. Like, this is changing, and this is also changing. This is also changing, right? You may observe a clear relationship, right? So how much this changes when this changes. I hope you're getting it. So we have covered the calculus, and we have covered the differentiation and integration. So what is differentiation? It just used to take out of the slope. Like, we simply find the slope of dy by dx. And what is integration? Integration is just a area under the curve. It's just a area under the curve, right? So I hope you given a basic understanding of this. So, and next we going to cover the functions. What are the functions, and what is composite functions, and what is parabola, and we have a trigonometry over there, and what is Sakatova, and we have a beautiful diagrams over there, and I'm going to clearly explain what all these, and we have a lot to cover. So I hope you enjoyed this lecture. So until then, bye bye, see you in the next lecture.